All right, we are in section 2. A couple of problems coming at you in this section as well. I like how this author brought this particular problem to our attention. It basically says, this is a differential equation if you look at this. This guy right here, dy dx, is another name for that guy is y prime. And our world in differential equations is y prime, y double prime, a system of differential equations, whatever it might be. And we're all about trying to find the functions that fit. So this is actually, from Calc 1, but we didn't know and we didn't call it at the time, but it is a differential equation. The derivative of the y function is found to be a function of x, which is 1 over the square root of x plus 2. So they're asking us to find a function that satisfies. So this is actually cool because we can actually solve a differential equation by taking the derivative equation, I call it, and integrating up to the function level from the derivative level. So that's what we do. We simply go, okay, what we'll do is we will integrate both sides, okay, with respect to x to find y itself. Look at this. Kind of interesting how this works with the differentials. Your dx's are going to disappear. And on the left-hand side, you're really looking at, put this in blue still, you're looking at the integral of dy, which is, there's an invisible 1 in there maybe, integrate it, and what you get is y equals. Okay, that's the start of something they call separable differential equations, by the way, that we study in Calc 2. But anyway, what we have is that integral, the antiderivative of the derivative of y. I derive y, and if I antiderive, I get back to y. So that's what happened. We get y. And on the other side, well, what we have is an integral that we have to try to figure out in this set of problems. And in this case, of course, or is it of course, I hope it's of course, that u equal x plus 2 du turns out to be dx. So this integral can be looked at as 1 over the square root of u du. And that is equal to the integral of u to the negative 1/2. And this is all Calc 1, isn't it? It's not terrible. And so you get u to the positive 1/2 over 1/2. Another name for that guy is 2 square root u, and then tack on a plus c. So our problem is becoming y is equal to 2 square root of u, but u is x plus 2, and then plus c. There you did it. We've solved our first differential equation in this class. Nothing special. It was kind of a Calc 1 problem. We just integrate the thing, and there we are. The second part of this problem, though, is for us to take this initial condition above, and from the last two videos, maybe, or the last video at least, we're going to plug in and use the initial condition. Remember, y of 2 equals -1 means when x is 2, y is -1. So we plug this in from algebra days. It's an old story. We plug in -1, 2 square root. We plug in 2 for x, and we figure out what c is. Pretty straightforward stuff. -1 is, what is that, 4. Square root of 4 is 2. This is 4 plus c, I guess. Tells us c is -5. So our final answer to this problem is y equals 2 square root x plus 2. And what is c? -5. Okay. I want to emphasize that once you find c, don't stop. You want to say, there's my particular solution given all the information they gave us. That's pretty much the homework here. It's pretty cool to use old skills to get here and before we learn some of the new stuff. All right, we'll see you at the next one.